So here we have the next question on the menu today, and it's asking us, or is presenting the situation where we have a parcel of air. You don't need to really worry about what this object is. You can imagine it as like, a tennis ball or whatever other type of object. It's because it's tough to visualize moving air, but the math is all the same. So it is moving in a straight tube with a constant acceleration of negative 4.3 meters per second squared, and has a starting velocity of 12 meters per second at 10:05 a.m. I'm going to assume that's 10:05 minutes with the 0 seconds. And so the first question is, what is the velocity at 1 second later? Okay, so let's actually draw out some of the given information that we have here. So our acceleration, negative 4.30 meters per second squared. Our initial velocity, let's call that V1, or VI for initial, is going to be positive 12.0 meters per second squared. And our initial time, so TI, is going to be 10:05 a.m. 0 seconds in. And I guess I don't really need to write AM because all of the other things are in AM, so it doesn't really matter. AM or PM is the same thing. Okay, so for part A, it's asking us what is the velocity at 1 second later. So part A, what we need here is our kinematics equations. Our final velocity, we know, is VF is equal to our initial velocity plus our acceleration for, however long that we do this. Okay, our delta T in this case is going to be TF minus TI, which is, 10.100501 seconds minus 10.0500 seconds, 1 second. Okay, so if we sub in our numbers, our final velocity here is going to be our initial velocity, that's 12.0 meters per second. Now we're going to add a negative number to it. That's nothing to worry about. That just means we're decelerating. Kind of like when you pump your brakes on your car, that's a negative acceleration that's happening. Multiply by the time, 1 second. Okay, so that's a quick math. VF is just going to be 12 minus 4.3. And that is 7.7 meters per second. Under that type of deceleration. And it's constant, okay, so we're always going to have that. Is that what we got here? That's not the acceleration. Okay, so I guess they just used the wrong acceleration value. That's nothing to be too worried about. Here, now it's going to ask what is the velocity at 4 seconds after here. So part B is just going to be the same, except this is going to be 4 seconds instead of 1 second. Part B, we're going to have the final velocity is equal to our initial velocity plus acceleration times our change in time. In this case is 4 seconds, so it's going to be 12 meters per second plus negative 4.3 meters per second squared times 3. Oh, you can't see that, my bad. Times 4 seconds, actually, my bad. Okay, so in this case, 12 minus, in brackets, 4.3 times 4. I guess we don't really need brackets. This is going to be negative 5.2 meters per second. Okay, so essentially you were going here, but you were decelerated so much that you started to go in reverse. It's pretty much what's going on here, and if they're still using the same value here, Unfortunately, that's not going to be possible. And the next part of the question is asking us what is its velocity 1 second before here. So in this case, for part C, we're going to have VF is, well, it's the same equation as before, plus A times delta T, except our delta T in this case is going to be negative. We're going in the past. So negative 1 second, because in the past. Okay, so our initial velocity, that's still going to be 12 meters per second, plus negative 4.3 meters per second squared. That's our deceleration. And multiplied by negative 1 seconds. Okay, so you see those negatives cancel each other out. So this is just going to be 12 plus 4.3. That's going to be VF equals 16.3 meters per second squared. Okay, and that's going to be the velocity 1 second before. Okay, cool. So that addresses part C of the question, and part D is describe the shape of the graph of velocity versus time. So as you can see, this kind of has like a y equals mx type, mx plus b type of feel to it, because you see that a is going to be constant, vi is going to be constant, t is going to be our only variable. So essentially what this graph is going to look like is, if here is our velocity and this way is our time, essentially it's going to look like a linear straight line like this. And the slope of this is going to be the acceleration, which is going to be negative 4.3 meters per second squared. Okay, so yeah, that will be what the graph looks like. Just a downwards line for the deceleration. If it was a positive acceleration, it would be an upwards line and the slope would be positive. Okay, so yeah, cool. And the last part of the question, argue for or against the following statement, knowing that a single value of an object's constant acceleration is like knowing the whole list of values for its velocity. And that is absolutely correct, because as long as we have one like starting velocity knowledge point, we can calculate at any point in time. So even if we were going like 1,000 years in the past, assuming a constant acceleration, we can calculate exactly what that velocity is going to be. Okay, so cool. This addresses this part of the calculation, and yeah, awesome. So the only thing that I got to mention here is that calculations were done, acceleration as 3 instead of negative 4.3. Process is good. Calculations are off. Oh man, that was the last question. Time flies when you're having fun, as the old saying goes. So those are all the questions that we have for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and ring the notification bell below. If you're interested in submitting your own questions, or if you're interested in getting some help with your homework or getting some help with some tutoring, we have links in the description that can help you with that. And if you enjoyed today's video, a like would be greatly appreciated, and if you really enjoyed today's video, we would definitely appreciate it if you shared with your friends. This has been Millen from OneClass. Today has been a great time with the physics. I had a great time, and I hope you had a great time as well. Remember that physics will never do you wrong. Physics is, it's always a good time. And yeah, stay safe, stay positive, and have an amazing rest of your day or evening or morning, whatever time you're watching this. Take care and keep on physicsing.